Welcome. In this video lecture, we shall discuss some simple real-time programs with 8086 microprocessor. To understand the content of this video lecture, you need to have some prior knowledge about 8086 microprocessor architecture, some important and simple instructions and their usage, and simple programming knowledge. Hoping that you are familiar with these concepts, let me move on to the content of the video lecture. In many places like shops, shopping malls, amusement parks, and in many other places, you might have seen the panels of LEDs in which some LEDs are glowing, some will be in off state, and some blinking. And you can also construct those panels of LEDs, and what all you need is only some hardware like microprocessor, interfacing circuit, and LEDs, and of course some simple programming knowledge. Now let me explain you the scenario for this glowing LEDs problem. For this we need one 8086 microprocessor, one interfacing circuit, and the LEDs. For the time being, you need not know what does this interfacing circuit consist of, what are its internal circuit, and how do they work. At this stage, it is just sufficient for you to know that this interfacing circuit consists of one 8-bit input port named PI and whose 8 input lines are PI0 to PI7. It also consists of one 8-bit output port which is named as PO, and those 8 output lines are PO0 to PO7, to which these LEDs are connected. The 8-bit input port receives its input from the microprocessor. The output of microprocessor is the content of AL, that is the lower order byte of accumulator, means the lower order 8 bits of the accumulator, which are given as inputs to the 8-bit input port of the interfacing circuit, and these input lines will control the output lines. PI0 will control PO0, that is L0, PI1 will control PO1, that is L1, and so on. For these LEDs to glow, they must be given a high input. For example, for L3 to glow, corresponding PI3 must be high. For L6 to glow, corresponding PI6 must be high. And here, the port address of the input port is assumed to be 00H. Now let us see a simple problem in which only one LED L0 is connected to the output port of the interfacing circuit, and we have to write a program to make this LED glow. We know that this LED L0 will glow if its corresponding input PI0 is high. So we have to load a data whose LSB is 1 into the accumulator. That is done through this move instruction, move AL, 01H. Now this content of accumulator is given as input to the interfacing circuit through this out instruction. So the content of AL 01H will go as input to the input port whose port address is 00H. As the LSB of this data is 1, the LED connected to the last line PO0 will glow. So this is how we can make this single LED glow. Now let us see how this single LED can be made to blink. The same content 01H will be moved to AL and it is given as input to the input port whose port address is 00H. Up to this it is same as the above problem. After this, to make it blink, we are going to put this not AL, means the contents of the AL are complemented, and now the contents of AL are as shown here, where the LSB is 0 now. The next instruction is jump up, where up is the label And now the next instruction that will be executed is the instruction with label up, that is out instruction. So the contents of AL whose LSB is 0 will go as inputs to the interfacing circuit. Since the LSB bit is 0, the LED will go off, and again not all. So the contents of the AL are again complemented and they will become now 01H. Now jump up, that is out, so LED will again glow. In this manner the LED is made to blink. Now pause the video and try to analyze the above program and identify the defect in it. Try it, else you can find the answer in the next slide. The program has got never-ending loop. So the program will be looping in between these instructions and it will never come to the halt. So at this stage you can try to write a program which ends after some n iterations. I am giving you the hint. You can use the loop instruction. Now we shall take up the next problem in which these 8 LEDs are divided into 2 sets. Set 1 consists of L0 to L3, the least significant to 4 LEDs, and set 2 consisting of L4 to L7, the most significant LEDs. Now we have to make these two sets blink alternatingly, and the condition is make initially all the LEDs glowing. So to make all the LEDs glowing, their corresponding inputs must be high. So you have to move FFH into the AL and out this content of AL to the port 00H. So all the LEDs will be glowing initially. Now we have to make these sets blink. For that we have to change the contents of the accumulator such that the least 4 significant bits are 1 and the most 4 significant bits are zeros. So for that you have to AND the contents of AL with 0FH. So the contents of AL are now as shown here. When you out this contents of AL to the input port 00H, then the set 1 will be glowing and set 0 will be off. In the next instruction we are complementing the contents of AL. Now the contents of AL are as shown here. Now loop up, so you go up and out the contents of AL to input port 00H. As the contents of AL are as shown here, so the set 1 will be off and set 2 will be glowing now, and this will continue, and set 1 and set 2 will be alternatingly blinking. And to make this loop finite, we are taking a number, in this case 10, and loading it into the CL register. For each completed iteration of this loop, the contents of CL will be decremented by 1. When the contents of CL become 0, then the program will be stopped. Which LEDs should glow and which should be in off condition is decided by this data with which you are ANDing the contents of AL. So by changing this data, you can get different patterns of the glowing LEDs. Here are some exercises for you. The aim of this video lecture is to provide you with some basic ideas and steps involved in the programming. The total programs may or may not be exact. Hope this video lecture helped you in understanding the simple real-time problems with 8086 microprocessor. Thank you.